Okay, hi guys. Tonight we're going to take a look at turning repeating decimals into fractions. Today's classwork and the notes from the night before last, we looked at fractions that were terminating and fractions that were repeating, and distinguishing between the two. And so today we're just going to focus on repeating decimals. So for example, like 0.83, where the 3 repeats. So there's a couple methods to turn a repeating decimal into a fraction. I'm going to show you two. So let's go ahead and get started. Okay, so on the top of your notes, if it's not already there, just go ahead and label, this is Unit 2-2 video notes, turning repeating decimals into fractions. I think this part is probably missing, so if you could just write that part in there. I thought I had it copied on there, but apparently I did not. So this part, if you could just write this part on your notes. That way when we go to organize our notebooks, some of us don't put these in our notebooks right away, you know which notes you're looking at. Okay, the first example we're going to take a look at is 0.5 repeating. And we know that 0.5 repeating is just that. It's 0.5555555 and goes on forever and ever and ever. So if we let x equal 1, then our x in this, or our decimal number, is 0.555. If we multiply 1 times 10, if we do this times 10, what we end up with is 10. If we do 0.5 repeating times 10, we end up with 5.55555. So we want to get rid of those decimals. So what we're going to do is we're going to subtract from 5.5 repeating, from this one, we are going to subtract 0.555. And what we end up with is just plain old 5. We got rid of those repeaters. But if we do that to the left side, we have to do that to the right side. So we did the same thing, 10 minus 1, and that gives us 9. So to change a fraction, we put 5 over the 9 like this. 5 repeating is just 5 9ths. Here's an easy way to remember it. An easier way to remember it is, if one decimal repeats, like this 0.5 right here, the 5 is repeating, then we need 1 9 on the bottom. If two decimals repeat, like this example over here on the next page, or on the right side, if two decimals repeat, then what we need is 2 9s right here. So let's just go ahead and do that. We're going to skip this top part. So all we do is we take the numbers that are repeating, or the digits that are repeating, and in this case the digits that are repeating over and over are 1, 2. 2 digits repeat, so we need 2 9s. And then we just simplified this fraction here by dividing by 3. We put it in simplest form. So if we divide that by 3 and divide by 3, we get 4 over 33. So let's do another example down here. If I had 0.27 repeating, 0.27. 27 goes on the top. How many digits repeat? 2. That's how many 9s I need. That's it. That's all you have to do. And then we could simplify this by dividing by 9, and we would get 3 over 11. So let's take a look at this example right here. If you want to try it by yourself first, that's great. So looking at the examples to the right, what do you think 0.360 repeating would look like? So we know that if we were to write this out the long way, this is 0.360360360. So we take the 360, the digits that repeat, and we put it on top. Since there are 1, 2, 3 digits, that's how many 9s we need. 3 digits repeat, so we have 3 9s. If 4 digits repeat, we have 4 9s. And then if we simplify this again by dividing, we can divide this by 9, and we can divide this by 9. We end up with 40 over 111. So what happens when not all the digits repeat? So in these first 3 examples, all of our digits repeated. The 3, the 6, the 0 repeated. The 1 and the 2 repeated. It was 0.121212. In the first example, the 5 repeated. So let's take we'll take a look at those in a second. So let's go ahead and try these. So 0.6 And again, the 6 goes on top. That's the digit that repeats. How many digits repeat? 1, so we get 1 9, or 6 ninths. If we simplify this, 6 ninths simplifies to 2/3. Go ahead and try 54 hundredths repeating, and then pause the video, try it out, and then check your answer. Okay, 0.54 repeating. The 5 and the 4 are both repeating, so they go on top. How many numbers repeat? 2, so that means that's how many 9s we need. And then 54 over 99, we can simplify that to 6/11. On this one, we divided by 3 to simplify. And on this one, we divided by 9 to simplify. Okay, last example. Whoops, sorry about that. Well, I guess that is not working. So the last example, I'll write it down here, sorry, is 0.123 repeating. So again, how many digits repeat? The 1, the 2, and the 3, they go on top. There's 3 digits, so that means I need 3 9s. And I can simplify this one as well by dividing by 3. And what I end up with is 41 over 333. We're going to try some more examples of these at the end of the notes. So now we're going to take a look at some examples where only some of the digits repeat. So, for example, in this one, the 6 repeats, but the 3 doesn't. In 0.951, the 5 and the 1 repeat, but the 9 doesn't. So I'm going to cross this part out right here because I don't like this. There's a simpler way to do this. I'm going to cross that out, and we can go ahead and cross this out. So let me show you how this is going to work. So let's take 0.36. So in 0.36, the 6 is the only one that repeats. So we're still going to write a fraction. How many digits repeat? Just this one, so that's how many 9s I put down here. But our decimal place value is into the hundredths place, so what do I do about the 3? Well, this guy, the 3, because it doesn't repeat, we're going to give it a place value of 0. That's it. The top number, we're still going to write down the 2 digits, but now, because we don't have both digits repeating, we're going to subtract the digit that doesn't repeat. And we end up getting 33 over 90. And 33 over 90 can be simplified again by 3, and we end up getting 11 over 30. So let me go through that again. We still make a fraction. We have 1 9 because 1 digit repeats. The 3 does not repeat, so we give it a 0. And if we do 36, we write down the 2 digits again, but we subtract the one that does not repeat because we gave it a 0 down here. So 36 minus 3 is 33, and we just bring over the 90, and then we go ahead and simplify. Let's take a look at 0.951 repeating. So again, not all the digits repeat. So we're going to make a fraction. These 2 digits repeat, so each of those get a 9. The 9 does not repeat, so that gets a 0. We still write the 951 on top, but we subtract the 9 because it does not repeat. And 951 minus 9 is 942 over 990. And we can simplify this one by 3 as well. And when we do that, we end up with 314 over 330. So 0.951 with the 51 repeating gives us 314 over 330. Okay, we're going to try a couple more examples, so flip your paper over. There's nothing on the back, but I want to try these examples together. So we're going to try these 4 examples, number 1, 2, and 3. So again, in number 1, trying to find my pen, sorry about that. So in number 1, we're still going to write our fraction bar. 2 digits repeat, so they get the 9s. 2 digits do not repeat, so they get the 0s. We write down the original number, which is 4354, and we're going to subtract the digits that don't repeat, and that's 43. When we simplify, 4,354 minus 43 is 4,311 over 9,900. We can simplify this by 9. And when we do that, we end up with 479 over 1,100. So go ahead, try examples 1, 2, and 3. Pause the video and then replay the video to check your answers. Okay, checking your answer on number 2. Here's our fraction bar. The only digit that repeats is the 8, so we only need 1 9. These 2 digits do not repeat, so they get 0s. 588 goes on top, minus the 2 digits that don't repeat, and that's 58. When we simplify, 588 minus 58 is 530. We can divide this by 10, and we get 53 over 90. Example number 3, make our fraction bar. 2 digits repeat, so we get 2 9s on the bottom. The 6 does not repeat, it gets a 0. 680 goes on top, minus the digit that does not repeat. 680 minus 6 is 674 over 990. And I believe that is in simplest form, so we're going to leave it as 674 over 990. And the last example, 5.484 with the 4 repeating. So again, the 5 is a whole number, so then we make our fraction bar. 1 digit repeats, so we need 1 9. 2 digits after the decimal place do not repeat, so we need 2 zeros. The 484 goes on top, minus the 2 digits that do not repeat. So what we end up with is 5. We don't need that decimal point. 5. 484 minus 45 is 439 over 900. And 439 over 900 is in simplest form already. So that is our answer. It's 5 and 439 over 900. We are going to practice with these extensively in class today or tomorrow. So if you have questions, please jot them down in your notes and I'll go over them tomorrow. Have a good night.